Okay, in this video, we're gonna go through our second method on how to find the limiting reagent. We're gonna use the exact same questions as we did for method 1. The only thing that's going to be different about these questions is that I'm not going to ask you to find the mass of the product. The only reason we're not doing it is because we've already done it for those questions in method 1. So the only part that's different about these questions is we're just going through the process on how to find the limiting reagent, and then you'd use the moles of those products to be then used to find the mass of those products, right? So let's take a look at the first example, which is a limiting reagent when 10.0 grams of Fe2SO4 reacts with an equal mass of NaOH. So our reaction is still going to be the same. So I'm going to just write it out here. Fe2SO4 plus NaOH gives us FeOH3 plus Na2SO4. I'm going to write in the coefficients as well. We balanced this in method 1. So we have the fully balanced reaction there. Now we're going to start off, as always, by finding the moles of whatever that we are given. I'm going to use a different color for each different compound. So for Fe2SO4 I'm going to use gray. So Fe2SO4. Let's find the moles of Fe2SO4. So 10 grams divided by, so for every 1 mole of Fe2SO4, there are 399.91 grams. And if I do this calculation, I will get 0.025 moles of Fe2SO4. So this is how many moles of Fe2SO4 I have available. I'm going to do the same thing, but this time I'm going to do it for NaOH. Let's use blue. So for NaOH, I'm going to see how many moles of NaOH I have available. So 10.0, I'm going to put the 0.0 here as well. Should have done that earlier. So for every 1 mole of NaOH, I have 40 grams. So that is the molar mass of NaOH. And using that, I'm going to find the moles of NaOH I have available, which is 0.25 moles of NaOH. This shows me, so both of these numbers show me what is available. These are the amount of moles of each of these reactants I have available to use. Now, unlike the other example, what I'm going to do is use the mole ratio between the reactants. Okay, so I'm going to compare these two to each other. So instead of using the mole ratio to the product, I'm going to use the mole ratio to find how many moles of NaOH is going to be used up in this particular reaction if I have this many moles of Fe2SO4. So doing this, so I will have to convert from the moles of Fe2SO4, moles of Fe2SO4 to the moles of NaOH. Looking at my coefficients, for every 1 mole of Fe2SO4, there are 6 moles of NaOH. Now doing this, I would find that there are 0.150 moles of NaOH that would be used if this reaction were to take place. I'm going to do the same thing here. Maybe I'll use a different color. I'm going to use the mole ratio this time solving for the moles of Fe2SO4. So using the mole ratio, but in the opposite way. Let's use, let's use green. So moles of NaOH go at the bottom, and moles of Fe2SO4 go at the top. So for every 6 moles of NaOH, there is 1 mole of Fe2SO4, which then produces 0.0416 moles of Fe2SO4. Now, just like I told you that we found the moles that were available, what we've done here in this column, we found how many moles would be used if these reactions were to take place with the amounts that we were given, right? Now, you have to compare available versus used. And here's where it's really important that you have your units correct. Because notice the moles of NaOH that are used are up here, and the moles of NaOH that are available are down here, right? So you're comparing these two numbers. And same thing for Fe2SO4, you are going to compare this number as the amount of Fe2SO4 available to this number, which is the amount of Fe2SO4 that is used. So these two numbers are what you are comparing. You will notice that for one reactant, the available is greater than the used. Okay? And you'll notice that for another, the used is greater than the available. So whichever one has available more than used, that is going to be your excess reagent. Whenever available is more than used, you have your excess reagent. And similarly, or actually not similarly, but if you have your used greater than your available, so there would be more Fe2SO4 used up than there is available, that tells you that that is going to run out first. That is limiting. So based off of our numbers here, can you identify which one is limiting and which one is excess? Let's look. So NaOH, 0.25 moles available and 0.15 moles used. That means my excess reagent is NaOH. Fe2SO4, available 0.025, used 0.04, right? In this case, the used 0.04 is greater than 0.02. That means Fe2SO4 is limited. So that's how you'd identify the limiting reagent using that second method. I'm going to do the second example as well in the exact same way. So let's use this color. So my reaction is still P4 plus H2 gives me PH3. 4 phosphorus on the left side, 4 phosphorus on the right. 6 times 2 is 12 hydrogen on the left, 12 hydrogen on the right. Same thing. I'm going to have to identify limiting reagent. Let me use blue. So P4, I have 62.0 grams of P4. To find the moles of P4, I have to use my molar mass. So for every 1 mole of P4, there are 123.88 grams of P4. Which will then give me 0.500 moles of P4. I'm going to do the same for, or actually I'm going to keep going. It doesn't matter what order you do this in, as long as you know which numbers are which, right? So let's use our mole ratio. You're comparing to the other reactant, right? So in this case, 0.500 moles P4. I'm going to use my mole ratio, so moles of H2 at the bottom. Oops, not H2 at the bottom. Moles of P4 at the bottom. Moles of P4 at the bottom, moles of H2 at the top. So whichever one you have moles of, you want to find the moles of the other reactant, right? So for every 1 mole of P4, there are 6 moles of H2, which then gives us 3.00 moles of H2, right? So this is available and this is used. All right, let's do the other reactant. Let's do gray. H2. So first finding the moles, 4.00 grams of H2. For every 1 mole of H2, there are 2.02 grams of H2, which will then give you 1.98 moles of H2. Again, this is the number of moles of H2 that is available, right? Available. And I'm going to use the mole ratio to the other reactant, so moles of H2 at the bottom and moles of P4 at the top. So for every 6 moles of H2, there is 1 mole of P4, which will then give you a number that is 0.33 moles of P4. Right, so you have to compare available versus used for each of these compounds. So I'm comparing the available P4 to the moles of P4 that is used. And then similarly, I'm looking at the amount of available moles of H2, comparing it to the available moles, the used moles of H2. So which one has available more than used? Let's take a look. So P4 has 0.5 available and 0.33 used. So that has available more than used. P4 is excess reagent. Which one has used more than available? So available for H2 is 1.98. Used for H2 is 3.00. So that means that H2 is limiting reagent. And that's it. That's how you'd find the limiting reagent using our second method.